What up, fellow member Rocketeers? I'm basically going over what I got right here, and slowly but surely got this finished. This has been metal spun, as you can see. Came out really good. This is a 304 stainless. It was an 1/8 inch thick, and it was spun out of a disc like this. See the sheet metal stainless steel disc, 1/8 inch thick. It was 304 though, not 3/16. So yeah, came out really good. You can just see just how nicely, perfectly round this thing is. Still pretty thick. Still pretty heavy. And look at how straight that is. Super smooth all the way down. Really nice. This is why I highly recommend metal spinning over using a slip roller. Because slip roller, you can slip it and start to bend it into the shape of a cone, into a taper. And then when you weld it, it starts to protrude like an imperfection bend at the weld. Almost like you would have to have it in a mandrel and secured in that mandrel nice and tight when you're welding it. And even so, it's not as perfect. So as you can see, this is really nice. And they just, at the shop, they just stick this onto the metal spinning machine. They drill a nice perfectly centered hole, and it's pressed up against the roller, and they use a rosebud to heat it up really hot, the piece that they're actually going to work with. So this part right here of the sheet metal, they're going to probably heat it right here in the middle, because that's where they start. And they work their way up slowly but surely, and they heat up this part right here, and then work their way up to the edge until they get this profile right here. And the profile is determined by the mandrel. So your mandrel should look like something like this, like what I casted, and it would be out of steel. So this would be a steel version, and it would have to be the exact angle of 19 degrees, between 15 and 20 degrees angle. So you got to make sure that they have something there provided for you that is relatively in that shape, and it goes down to 2 inches, this hole right here. So as long as they have that, you're good. If not, you would have to machine it yourself and then take it to your nearby metal spinning shop and make sure that it's to the correct measurements to their machine that they have. And so it's got to have a hole, or it has to have a protruding shaft coming out of the mandrel. So that way the sheet metal can slip right into the mandrel on the face portion of the mandrel right here and be perfectly centered. And because it's applying so much pressure, you don't want this to slip out for any reason, because it's so thick and because of the material 304, it needs to be secured in there really good. So having the machines at the shop are so much better, because the machines I have, or the machine I do have, is a lathe, and it's not as heavy duty. I can only do between 16ths of an inch thick or so, in that range. I can't do anything 1/8 inch. But it's a lot easier than machining a chunk of stainless steel like this, a small version. But this took me about a week, because I had a small lathe, and this could take, for them to metal spin it, it takes between 5 to 10 minutes max. So just setting up is what takes the most time right there. But yep, so I've been busy, I've been busy trying to do this, and I've also been busy trying to get my new sidecar motorcycle fixed up, because I just got this, and as you can see, I'm doing some work on the engine. So that's the other project I'm doing right here. So I gotta get new gaskets, cylinder gaskets, and I'm trying to troubleshoot the wiring, because the wiring's not correct. And I got new mirrors coming in. New seat is going to be fabricated inside the sidecar. I got new intake manifolds for the air filter that connect to the air filter to the carburetor. And I got a new air filter assembly, the case in the box, new air filter. I got a bunch of parts coming in. So I'm going to be putting this thing together. And I'm also working on my airplane too, so I need to fix that up too. It's almost done. I just need to get the cables put on, installed, and a new fuel line. And I should be able to test fly my airplane soon. But yeah, I need new fluids, new oil. I need new transmission oil, new oil for the engine. Yeah, so everything is slowly getting there, little by little. I got a lot of projects going on, and I also got my gazebo over there. I got a greenhouse going on over there, so I'm gonna be growing some vegetables soon. So, yep. So this is pretty much it. So yeah, you guys already seen this. So now I need to do the divergent section, which will be this guy right here. So this is the wood version. So I can't do steel or stainless steel. I could probably do aluminum with this, but this thing is useless to me. I just machined this block of wood for no reason. Well, you learn as you go. You start learning these things, So basically that goes there. So just like that when it's done. So this will be the stainless steel version. It won't be this long. It has to go all the way down to 7 inches in diameter. And that is also determined by the angle of your nozzle too. If it's between 20 or 15, that can also fluctuate the flow, the pressure of the flow, the exit velocity and exit pressure. You want to equalize to the ambient pressure. Everything works together, properly, and they have to be according to the size of the engine, the components, the combustion chamber, the length of the combustion chamber, the nozzle diameter, the fuel you're using, the oxidizer you're using, and the divergent length, the divergent angle, even the convergent, even though that be such a big difference in change. You know, it's just the flow entering into the throat as easily as possible without creating too much heat. You know, if it's constricted down too narrow, that could cause too much heat buildup alongside the walls and towards the narrow section of the throat. So you got to make sure that the you know, right here on the throat section is, you know, somewhat rounded off, and the transition is a lot easier for that hot exhaust to enter into throat, and then converts into kinetic, and then after that is all depending on the size and the dimensions of your nozzle according to your engine size. So yeah, that's pretty much the gist of it. A lot of careful calculation has been going into this, and yeah, so this should theoretically work. I'm hoping it will work. So I do have these plans here for people to have if they want. I'm sure that you guys would rather wait until I actually do the testing of this engine to see if it actually works properly and sufficient enough, and start to get some numbers logged into some data sheet that I'm going to have, and start punching in certain numbers and heat. I'm going to run thermo stickers. So basically these little sticky pads that go on to certain portions of the engine, and it will automatically record the temperature, and it keeps it logged into the actual sticker. But they only go so high. I mean, obviously you wouldn't want to have it on to this portion of the engine where it's over 2,000 degrees, but that's why you would have a special, you know, thermocouple lead probe that would be inserted right here, and that way you can record that. So I would have it somewhere right here on the hottest section and on to the actual bell of the divergent section. So, and as well as the combustion chamber and towards where the bulkhead, aka injector plate, would be. So I want to make sure that the temperature of that is adequate temperature and not too high. So that's pretty much it. So I'll keep you guys updated, and yeah, that's all folks.